I'm super excited to be part of this panel today with such a lovely audience today. And I'm joined by three amazing people. And I'm going to start with Danica. She is leading one of the DevRel teams at Snowflake. And Snowflake is, for the ones that don't know what Snowflake is a native data warehouse that evolved to be an AI-powered data platform. Then Philipp is head of DevRel from Elastic. The ones that don't know Elastic is the company behind Elasticsearch, powering search, observability, security, and AI-powered retrieval. And then finally, Till, and he's AI lead at MotherDuck, the company bringing cloud-scale analytics to DuckDB. For the ones that heard of DuckDB, I think it's very popular nowadays. And I am a moderator and also a participant to the panel, so I'm going to make this weird thing and introduce myself as well. I am Monica, I'm the founder and CEO of a company called Xata, and we are building Postgres, a platform for agentic workloads. Basically, we give every agent its own database and isolated environments where they can test end-to-end with production-like data. And what's special about and unique about this panel is that I wanted to have people from different data layers. They are part of the modern data stack to kind of discuss about how AI agents are reshaping data platforms. I think more and more discussions are happening lately about AI agents, and we have similar experience ourselves how they shape the modern data platforms. For decades, the data platforms had as a user the humans, and now we have a new user that we have to think of is the AI agents. So I will start with, the most obvious question, and I will start with Danica here. And data platforms were designed around humans. What's fundamentally different when the user is the AI agent?
Yeah, so first of all, before I get into my response, I just want to say that I think Snowflake has specifically a unique vantage point on this topic because, like everyone else here, obviously we are going through changes to accommodate external agents that are working with our platform through APIs and MCP. But we took it a step further, made things more difficult for ourselves, and we actually launched a new part of the product that is sort of the agent of all agents. So we call it lovingly Coco. So I'm going to be talking through as I'm answering a lot of these questions, speaking through that lens a lot. So since its launch earlier this year, we've now seen a lot of the previously human workloads that would have been kind of hitting our platform directly and interacting with our data there. They've been shifting to actually do everything through this new agentic coding assistant that we've launched. Now, to actually answer the question, so what's fundamentally changed between human users and agent users? I think the biggest thing is context, right? Agents are stateless by default, and so when a human, for example, is tackling a data-oriented task on Snowflake, they approach it with a lot of institutional knowledge or baggage, whatever you want to call it, years worth, right? They know what table matters, they know what revenue means in this context, they know who owns what, right? And an agent just does not have that by default. And so what we need to do is the problem becomes surfacing what is implicitly known to the human, and now making that explicit so that the agent now has this accessible to them programmatically, and it's queryable, right? They have access to the schemas, the semantic layer, the lineage, everything that they need. And so the shift now has become, okay, we have this data platform, but now it's becoming a reasoning substrate for all agentic activity, right? And so the metadata layer for us has become sort of the most important piece. That's the hot path for our platform. It almost has nothing to do with the Snowflake as a query engine, as a data platform as a whole. Really, we're looking at the metadata and making significant investments there. How to make that faster, how to ensure that the data is structured properly to, again, feed that to agents and give them as much context as we possibly can.
I totally agree with you. I think agents, I think from my point of view, they work very differently. You know, before a human, in order to get a solution or to get the answer to a solution, they were trying one or two paths, and then they were trying, they were finding one of them was successful, and then were finding a solution. With agents, this is totally different. Agents, they start many dozens of parallel tracks and try different things, and then one maybe some fail, some succeed, and then retry again, and so on. So basically, it's hard. It's just the trial and failure is just more out there than in the humans era. And I think what changed is that before AI era, you used to have companies, they had one production database, one or two staging databases, and now with agents, you cannot really give all your agents the same staging database. We know humans, they were able to, queue for a staging database in order to be able to test their code, but, it doesn't really work with agents because they are doing so many of tries in parallel, and many of them, right? So I think I think for us, what we see is that staging database becomes a bottleneck. Especially imagine that you have your agent that they need to test a schema change, or they have to do some rollback that they have to test. This is something like operations that change the database, and it cannot really share the database. So I think we are ending in an era where we see that you kind of need to give each own database to each agent in order to be able to test end-to-end without affecting other workflows from other agents. So I think what changed is that before you used to have one or two databases, one production, one staging, and now the requirements are different, are shifted in the sense that you need many more databases to support all your agents' workflow. And I'm curious about Philipp. What do you feel like for Elastic, in the Elastic perspective, how this changed?
Yeah, I'll build on Danica's context. We'll keep that. And I think Monica's point about like the retries and exploring things, we'll also build on that. But let me switch my perspective slightly more to the query layer, and then of course search. Obviously search is core to what we're doing. But the thing that, or one of the interesting things that we have seen is like when you see or watch humans interact with your search queries, it's oftentimes that they enter 1 to 3 search terms maybe. If you let agent search, they probably use very different patterns. Like we've seen agents that search for 20 different terms. So the shape of the queries are suddenly different. It's not just the volume and the retries if you do not get to a result that you have been expecting, and then you kind of like keep trying until you get to a result that is interesting. But it's also just the shape of queries is potentially just different. And then you'll need to tune the internals and the performance around that, both in the volume, but also just like how complex or complicated the queries are. And the other interesting aspect could be that oftentimes you have a very powerful search box, but many of your users are not very powerful users, and they just like type in 1 or 2 words without using any of the like negations or combining things, or things need to be close to each other. If I think about my parents, they would use a very simple search in many cases. But with agents, if you give them enough context, they can actually formulate much more powerful queries. So suddenly a larger part of your user base can formulate very expressive queries in your search engine, which gives you another tool in the box to just get you to results that you couldn't get to. So the agentic search world just gives you a lot more options about like, how powerful can I make the queries, but also I don't get great results. Let me reformulate that. Let me maybe add more synonyms that nobody has thought about, or let me broaden the query scope. It's really a different experience that you get at the end. But it's also that the agents just interact with the system differently, just taking it to the query level.
Yeah, I can relate to that also from an analytical database system perspective. So when we started our company, MotherDuck, DuckDB was already out there, and one of the observations that our founder made at that time was that he was working at BigQuery at the time, and he noticed that a lot of workloads that customers ran only queried a small subset of the big data that was there, and that led to this insight that basically DuckDB is an engine that can probably cover 99% of workloads that people typically run, even when they're using larger database systems. And so what these queries are, they're looking at smaller time slices and so on, or there might be exploratory queries. So this is this query pattern of many small queries rather than few big queries. And that pattern basically got amplified by agents writing queries. Because what agents typically do when they start an analysis is that they start listing catalog metadata, and then in the next step they run like limit queries on the data set to get a sense of what the data covers. Of course, like having a context layer or semantic layer helps with that. Like it reduces the need of the agent to do as extensive exploration, but especially for things that are not covered or not explicitly expressed in these semantic layers, agents still need to do extensive exploration. And agents can write SQL much faster than humans can. So they overall create a higher volume of queries. And we focus at MotherDuck on creating a system that really works well for these high volume query workloads. And yeah, that basically is something we believe that will become more important the more clients of the database systems are becoming agents. And yeah.
Thank you, Till. So the second question, what's the biggest assumption your platform made about its users that no longer holds in the agent era? And I'm going to start with that just to start the discussion. I think before we assumed that creating a database was a very rare operation, that you know, like how many times you had to create a database. You created your database and your application, you're using it, and you are keeping it running for a very long time. And I think with the rise of AI platforms like Vercel, Netlify, Lovable, statistics say that more than 80% of those databases are created by agents. So basically, we have agents as a first user citizen for managing and creating databases. And agents are different than humans, right? A human maybe can have the patience to wait for a longer time for a creation of, to start a database, to create a database, to start a database, but agents don't, right? They have to really, have it in a shorter period of time, so they are not blocked during that time, right? Because they can do other important operations. So I think there is a shift in that creation of the database is something that happens too often. It happens very often now with agents. And also, if you think of like an agent needs a database for a specific period of time, usually a short period of time, imagine that you have, imagine like you have in Netlify, you have this workflow that you can basically see your pull request end-to-end with the front end. And I think it will be nice if you can also see end-to-end, including the data layer, right? And in order to be able to do that, basically you can create a database for your agent, and then be able to see this end-to-end, including the data. Ideally production-like data, so you can kind of see better the results as if it was in production. And things like this, the agent needs the database just for, maybe a few minutes, maybe less than that, and then basically it just drops the database. So I think things are changing in the sense, from my point of view, where we sit in the Postgres world, where we see that databases are needed much often than before, and they have to be ephemeral, so like for just a short period of time until the agent is doing its work and then it's dropped out. So what we see is that now you need more databases than before. And I would love to hear, Philipp, from your perspective, how do you see what's the biggest assumption that you guys did?
Yeah, so one funny thing that when I think back at how search engines, for example, used to work, and I'm pulling it slightly over to the query side again, it's like back in the day, when a query took more than 150 milliseconds, people would complain that this was too slow. And now that we have agents, like we're often much more forgiving in timing, because then the agent is kind of like noodling and like working out a full report or giving you a perfect answer. And we're a bit more forgiving of like the end-to-end time. Each single query still needs to work fast, and maybe you have to parallelize more, but the latency is just weirdly changed of like how things used to work and how we're perceiving them today. We're just, maybe because it's the novelty, but we're a bit more forgiving in that. A different aspect is that previously we often invested heavily into UIs or helpers to do something. Now with agents, you often don't need those so much anymore. And I think then Till and I have like this discussion point about like the right query language. Like in Elastic, we don't use SQL anywhere really. And there is this, I think, ongoing debate is like, are query languages important with agents? Are they more important? Are they less important? How do you formulate your queries? Because I think the point of view that we take a bit is like, you can have any custom query language as long as you provide enough context. An agent can just write it, and no human needs to learn it. So it doesn't really matter so much what the query language is. But I think your perspective on that is, of course, slightly different.
Yeah, I mean, DuckDB is not has not been around for that long. I think it's 7 or 8 years now that it has been out there, and DuckDB is known for having some like nice SQL dialect extensions that make it a bit nicer for humans to write SQL. Like there's some features where like group by all, for example, or other expressions that really make the SQL developer lives easier. But at the same time, it's a feature that is not very very well presented in pre-training data for language models. So that leads to a situation you have this nice feature similar to this aspect of having AI assistants in the UI and so on. There has been a lot of focus on making the SQL developers' life easier. But now suddenly with most queries being written by agents, that gets less and less important. And basically what starts to matter more is what part of the language has been well represented in the pre-training data. And so we've also started to like tackle these dialect extensions basically by adding context to the language model, but it adds a little bit of complexity on the infrastructure side, because we have to create a retrieval pipeline from the documentation and so on. And yeah, at some point, I think we can assume that new languages or new query languages will be harder to for models to learn, and it will just be maybe conversion back to what is already out there, not so much in need of new languages. But I guess like especially like Elastic has been around for long enough that a lot of the functionality is already well represented on the web and in documentation. Yeah.
What about you, Danica?
Yeah, so I'm going to switch gears a little bit and talk a bit more about sort of the intent of what we're actually doing when we run queries. So, and the biggest assumption that is kind of broken down now is that with humans, we could mostly assume that they're checking their work right? Like if you are querying Snowflake and you are given a result set, a human wants to eyeball that and check it, and they intuitively know like if something's off, right? Revenue shouldn't be negative. Cool, I should rerun this and try to figure out, okay, was my query incorrect, right? Or if they're familiar with the data set, then if a row comes back and it feels off, they're going to dig into that. But an agent may not do that. Right? They don't have, going back to sort of the context on there, they may not do that. And going to your point about, query languages, does it even matter if the agent's writing the wrong query to begin with, right? We're not serving anybody. And so an agent will receive the wrong result back and will confidently, frustratingly, feed that into the next stage of whatever workflow you're currently running, right? And obviously that error is going to compound and nobody is happy. So our platform can no longer assume that anybody's actually checking and has eyes on this, and they're happy with sort of the results that are being fed back to them. And so what we've started doing to mitigate this is really focus on, okay, what guardrails can we put in place to kind of better align with what the original intent of that query actually is, whether that's triggered by a human or an agent. What guardrails can we put in place to better align that intent with the result that we're actually feeding back to them? And there's a couple things we've done. Verified tables. So at sort of the organization level, you can establish, oh, this table is safe to query from for these certain things. And you can kind of assign that in the semantic layer. Taking it a step further, we also have verified queries. If there's specific pieces of data that you're querying for, great, we can establish that query as being the right one. Business definitions and extra metrics in there. But really, again, we're leaning on the context here and the semantic layer. And we're seeing that the semantic layer isn't just a nice to have for certain subset of power users. It's really becoming the correctness mechanism at this point. And I think that this is actually even more important for external agents that are engaging with our platform than it is for Cocoa, because at least for Cocoa, we can run extra validation loops if something feels off. We have the ability to do that. It's within the platform. But for external agents, once that data sort of, they're executing a query using our APIs, using MCP, great. Once that data is fed back, it's out of our control. So how do we know what they're doing with it? So again, the only thing that we can do is kind of take these extra steps to try to, like I said, align that intent as best as we possibly can with sort of what the business is trying to do.
You mentioned some of this, but I think it's kind of related to the first question. Agents explore, retry, and make mistakes, as we discussed so far. And I want to hear about from you guys, what does your platform need to provide to support that safely? And I'm going to start with Danica, because you already started discussing about guardrails, and you can tell us a bit more about this.
Yes, there's a lot of things that we're doing, and three big things especially, and a lot of this is coming out of the development of of Cocoa, of the agent of all agents, right? But obviously it's relevant, I think, for any of the external agents that are hitting our platform. So I think transparency, governance, and having sort of sanctioned patterns, or leaning into skills, right? So for transparency, we can't. Agents are always going to be doing things that we don't really expect them to do, right? Things are getting better, but we wanted to make sure that every action that an agent is actually doing on our platform, whether that's external or something that Cocoa is actually kicking off, we should be able to trace that, right? We need transparency into what they're doing. We need to be able to audit every stage of that. And in many cases, we actually provide the user with the ability to review certain changes before they actually go through, right? And this isn't just, a developer experience nicety. I think that this is, a critical sort of safety model that we need to have in place so we can properly review things. Because the last thing we want is an agent sort of retrying something 50 times, not getting anywhere. And we should know that that's happening so that we can review it and figure out how can we tune to account for this later. And so for the governance piece, I think this is actually the biggest design decision that we could have possibly made for Cocoa especially. But it was honestly an easy decision just because of the nature of our platform and how we set it up already. But when the user is engaging with Cocoa, everything they're doing is running as that user. Okay, it's not some super user account. It's not a system admin. It is running as the individual. And so this gives us a couple really nice things. The first is that we can very neatly tie everything, every action from an agent back to a user. All right, so that leads into sort of that traceability and transparency, right? But then beyond that, because of the way that we've set up governance on our platform, we have a very, very robust governance layer. And so this means that all of the governance that's set up, that's on top of that user, is now inherited by the agent. Okay, so the role-based access control that we have, any of the masking of certain fields, that's inherited by the agent. Row-level security, that's all in there. And so this is obviously an extremely important architectural decision, and I'm glad that we did it because it makes this safety model architectural rather than instructional, right? Because it's never going to fly to feed into a system prompt, hey, ignore PII, right? So we have to have this baked into the governance model from the beginning. And then finally, with the sanction patterns and skills, Snowflake's a sprawling platform. There's a lot of different technologies and pieces of it. And so to the degree that we can have domain experts actually setting up established workflows with best practices sort of built in with the right way for an agent to engage with this particular part of the platform to achieve XYZ, we should be doing this. And obviously, this is benefiting Coco because we are able to bundle all of these skills for our users of this internal agent, but we also make a lot of those available sort of open sourced for external agents that want to be engaging through our APIs and MCP as well. So yeah, I think the goal of the skills especially is, for the agent's perspective, how do we make the safe path the easiest path? Because that's really the only signal that they're going to be looking for.
Great. From our perspective, a company that is running Postgres and also is using coding agents to generate the code, we see the guardrails are very important. I agree with you, but we also see that sometimes they are limited, especially imagine that you are an agent and you need to test like schema changes or rollback or any data changes. Then it's not really possible to pass the same database to every single agentic workflow. So it's you kind of need to have, as I mentioned before, you kind of need to have an isolated database for each of your agentic workflow in order to be able to test in isolated environment and without even touching other agentic workflows or interfering with other workflows. And we've seen in the last months there were a few cases in the press where the agent was connected to the production database and decided to delete the database. And it's like these are like the first things that you hear, and people are getting scared of. And that's why we think that the solution for this is to give an isolated environment where the agent can test with production data. Because why you will gonna connect the agent directly to the production database? Because you really need the data. So that's why I think it's important not to give to an agent an empty database, but provide it with production data as well, so they can test really end to end. They can understand better the schema, the data, if they can really have access to the real data. And back to PII information, many companies will have the fear to give an agent the real data. So it's really important to be anonymized if you are very strict about this. So I think these are the things that we see, and I would love to maybe hear from you guys. Let's start with Philipp from a different perspective.
Sure.
How you feel about this?
So maybe we kind of like try to hack the system a bit, or we try to approach this slightly differently, especially for analytics workloads or also many search workloads. We would not even need to give the agent write access. So we would just give you read access, which solves like, I don't want to say half of the problems, but it solves many big problems. So you will probably never run into the situation where the agent just dropped all the data. And then we can kind of like circumvent a lot of the sandbox discussions. I think for us, the approach about like PII data would also be much more at ingestion time to clean up the data there, that no matter where the agent goes off the ramp, there's a certain amount of data that is just not available or that is just masked from the start. So I think there are places where you need to have of course, you need to have the observability and you need to have the guardrails in place for certain use cases. But in some others, you might get around that by kind of like putting the ingestion time limits in place where you have only read-only access or you mask certain data out. Also for the agents coming in from an RBAC perspective, we also have the model that you would also always come like from the user that is inheriting the permissions. So you could always tie it back to that. Maybe at some point there is the need to have a concept outside of that scope of a specific user, maybe like a super user that has access to the data that can trigger on certain conditions. Things like that could become interesting. Right now, we're just hacking it by having a super user and then having an agent tied to that. But maybe at some point, we will have more agents actually independent of the users that you have in your system. And then I think the other problem areas that you have now that you have this new user that might run way more queries, you need to sustain the load of that new user that not just runs one query every, I don't know, half minute or so, but that might fire 20 different queries in 10 seconds, and how you deal with that in your platform. Those are all things that a platform needs to deal with and how you can work with that. And those are some of the problems we are trying to tackle. And then, of course, the context and the semantic areas are around that, but there is this foundational platform aspect to agents, like how to work with them efficiently.
Yeah, maybe just for the fun of it, I add like a slightly different take on this, the need for strict guardrails. Just like based on we have an MCP server interface for MotherDuck, and it has been read only for a long time. Until we've seen like an increasing demand for people to can I just, like, I really want the agent to just create a new table off of this that contains like a subset of my result, or I would really wish I could just like simply ingest this CSV file. So more of the ad hoc kind of workflows, and we've added something called database snapshots to the platform some time ago. So it allows users, or it allows the system also to do it itself, but to create a zero-copy clone of the existing database. And we're talking about analytics workloads, right? So MotherDuck is a database that's typically used by people that want to analyze data, not necessarily a backend system for a web application or something like this. We're powering data apps, but many of our users are also using MotherDuck for ad hoc data exploration and analysis. And then adding this write functionality to our MCP server and to make it accessible to agents has been very liberating. And we have seen very few we've seen no customer complain about, oh, the agent just randomly deleted this data set that was very important. What we have seen sometimes is that customers really want to limit this ability specifically because they want to make the system accessible to users they don't trust to that degree, let's say. So what this means we need in the platform is scoped, or like sorry, fine-grained permissions, so we can, depending on who is authenticating, signing up, we can hand out permissions for write access or for read-only access and so on. And also there are admin features on the platform, for example, in inviting a new user and so on. And also those permissions are really should really be handed out on a use case basis. Some people really want to automate like their entire workflows with an agent, and they really need these permissions for their system to work. But others, of course, want to lock this down more. So I think giving control to the user through fine-grained permissions is really important.
Great. And I mean, we talk about a lot about how we think the agents or are affecting the data platform. I would love to kind of hear from you more concretely, looking back over the last 12-18 months. Let's say, what are the biggest product or architectural investment that your company made to support AI agents? and what was the problem that we were solving. And let's go quickly. Maybe Danica, you want to be first this time?
Yes, I don't know if anybody's counting how many times I've said Coco yet, but that's the fact that we kind of challenged ourselves to build this as part of our product, to build this ultimate agent internally. It surfaced as we were rolling it out incrementally. It surfaced any of the gaps that we may have had, and by then addressing those gaps, we were able to, obviously better serve our internal agent, but obviously those changes are going to serve our external agents as well. So things that we saw about, okay, metadata isn't being serviced as quickly as we need it to, or things as simple as error messages are more human friendly, right? How do we, actually expose those in a way that are understandable to our agents? So we really used the rollout of Coco, of this part of the product, as a stress test for all agentic activity across our platform. And I think that it's obviously worked, as I mentioned. A lot of the human traffic that we used to have directly on the platform has now been redirected to go through this agentic tool. So a large portion of our traffic now on the across our platform is now agent based, which I think is really exciting. And we've seen, I think, over 50% usage from our customers in the 6 months that we rolled it out. But beyond that, another big thing that we've done over the last year or so is kind of addressing the semantic layer. So a thing that we saw as we were working across both our agents and seeing what external agents are doing is that it's not always the case. When you look at an individual agent, they're not always just working with a single data platform. And so even if we go to great lengths to ensure that our semantic layer is perfect and beautiful and it does exactly what they needed to do, then great, they're also working across another platform with similar data, but the semantic layer there is completely different and there's no alignment between the business definitions. Yeah. So it doesn't matter what we do if you can't actually align it for the agents that are working across platforms. And so to address this, we brought together folks from across the industry and launched a new open standard for we need more standards. Yeah, a new open source project called the Open Semantic Interchange to specifically address this. So it is a vendor neutral semantic format to specifically address this problem so that we can all align outside of our own sort of limited semantic layer. And this is something that I'm especially excited about, personally, and for my team. I lead the open source developer relations team at Snowflake, so it's really cool to launch this, to put this out there, and to kind of work in growing its adoption to better serve this use case.
Thank you. Philipp.
Sure. So it will probably not surprise anybody, but from our perspective, a lot of the agentic problems are retrieval problems, like memory, to a large degree, retrieval problem. Context that is only existing in your organization, a retrieval problem. Even with very large context windows, you still have retrieval, or you don't want to confuse your agents with too much data. So a lot of that is retrieval as a core of all the things that you do with agents. So there's something where we have deeply invested. Is it like vector and hybrid search? Is it semantic context that you want to add? All of those things are very important, and we have focused a lot of our effort on like fixing these retrieval problems. And I think, or I hope I can speak for all of us as well, is that even with agents and AI, data stores are not going anywhere or going away. Like, you will always need to keep context or the observability data that you will build on, or security information, or just like what has happened in your company. All of that still needs to exist somewhere. So that retrieval part is very important. And yeah, Elasticsearch has been doing retrieval for 16 years, and it's just evolving and getting better. So that is what we have been focused on. Till.
Yeah, so many of our customers are small to medium-sized businesses, so companies that don't have like a 20-person analytics team, and also internally we're using MotherDuck, and we are an 80-person company, so we're kind of representative of our types of customers. And like since we launched our agent integration, we've seen so many non-technical people basically getting their analytics straight from the source. Instead of having to go to an analyst or having to configure a BI dashboard, they can now basically get their insights straight from the source, and that's where like context becomes really essential, or the context layer, semantic layer. And the aspect I want to add is that with all these additional users coming to the platform that are not technical, they're not SQL developer, they're not trained analysts, but they have a very, very good understanding of their business and their business domain. So we have people across the board from sales to management and whatnot in a company that are building their own dashboards now on our platform. We have basically an agent integration that lets people basically deploy a TypeScript app that is backed by MotherDuck, and it can run live queries, and the user doesn't need any programming or TypeScript knowledge to do that, similar to cloud artifacts. Maybe you've seen it before. But yeah, it has been very, very liberating for these people. It's very simple to get to the answers they need, so they can continue what they wanted to do. They just needed a specific insight that is somewhere hidden in the data. And it's so we kind of call this the right-hand side of analytics, like the layer where you consume data that is stored and processed in the data system. And then there's the left side of this, which is the ingest. Oh, I have this Excel spreadsheet, I have this CSV file, or I have this Postgres database here that I would really like to combine with the data that is already in my warehouse. And so to come back to this language point, Python is really the lingua franca for data engineering. So we will launch a similar feature to these dashboards also on the ingest side, where we allow people to basically have an agent develop a data import flow, and they can schedule it, and so that in a way the amount of people you need to run analytics in a company is getting really low, and the people who own the problems are also able to interact with the platform. And what comes with that is you get all the business context from that user, from those users, right? There's typically always a lot of forth and back between analysts and business users about what the actual definition of a specific metric is, and so on and so forth. But when you bring this business user into the loop, you can build up this knowledge over time. So I also really like this this direction of semantic layers, context layers. So we so that users that interact with the platform together with agents can build that business knowledge in the platform over time together collaboratively, and that's something we want to enable going forward.
Thank you, Till. I mean, in the Postgres world, so I can speak about that. Besides the usual, running Postgres in production, what we see a new major use case that is rising now, when we call it agentic workflow. And I mentioned a bit about this before. Basically, what it means is that we give every agent workflow its own database, an isolated database where they can test with production-like data. And in order to implement, with the traditional database infrastructure, this is really something that is not really possible. Imagine to create so many databases in just a short period of time, and also use them for a short period of time. There isn't really the traditional database infrastructure doesn't really work for that. It's too expensive, first of all, and then it takes a lot of time. So we implemented a feature that we call it copy on write branching. Basically, you can branch from your production database and you have the same data as in production, but without really cloning the data. So regardless if you have 50 gigabytes of data or hundreds of terabytes of data, it takes less than a second to create that branch. It's very cost efficient because you don't really pay for storage every time you create a branch, because what's happening is that it's not copying the data, it's just passing like setting a pointer to the parent, so it feels like it's the same, it's the data there, but it's not really copied all the time you create a branch. So it's very cost efficient because of that. You only pay for compute, you don't pay for storage. And you know, all these databases that I mentioned, they are needed only for a short period of time. They need it for a few minutes and so on until the agent is doing their test, try things out, and then is basically killed. So for this, we implemented another feature is called scale to zero. Basically, every time the agent is hibernating, every time it's not active, it can not the agent, the database automatically hibernates when it's not active. And basically with these two features, copy and write branching and scale to zero, you can have thousands of even more branches that you can create for your agent at a very cost efficient. Basically, they are coming more or less for free. And then I think, you know, like with all these AI platforms, imagine an AI platform that has 10K of users every day, you can easily reach the scale of millions of databases active at a single time. And we've seen this by partnering with different AI platforms out there. So this is the scale that we are building for. And I think I wanted to highlight to kind of see like this is kind of what AI agents are kind of transforming, at least in the Postgres era. This is what, you know, the changes are done. And with that, our time is up. I really want to thank everyone here. They had to fly for this panel, so I really appreciate taking the time. It was really good to have you here. And now if you have questions, just because we are out of time, if you have questions for us, we'll stick around a bit happy to answer any questions you guys have after the panel. And yeah, thanks for attending the panel.